According to the National Electrical Code, it is permissible to use 8-3 copper Romex with the ground wire, which is designated as 8-3WG, to supply power to a 50 amps 2-pole GFCI breaker specifically intended for hot tub installation. This configuration adheres to the safety standards outlined in the NEC for residential electrical systems. The ground wire within the 8-3WG cable assembly must be insulated. These insulated ground wires are identifiable by the green color coding or by being bare copper conductors marked with a green stripe. The purpose of this insulation is to ensure a reliable and safe grounding path, minimizing the risk of electrical shock. The National Electrical Code does not allow the use of bare aluminum conductors for grounding purposes. Consequently, using number 6 aluminum service entrance round or SER cable to feed the 2-position panel is not compliant, mainly because it lacks an insulated ground wire. If the intention is to use aluminum wiring to supply the 2-position panel, several alternatives are available, each offering the necessary safety features and compliance with electrical codes. Firstly, there is the option of using number 6 aluminum SER cable with an insulated ground. This specific type of cable incorporates a dedicated insulated ground conductor, ensuring a safe and reliable grounding path, which aligns with NEC requirements. Secondly, number 6 aluminum type SEU cable can be used. Type SEU cable is characterized by having an insulated grounding conductor that is wrapped around the neutral conductor. This design provides effective grounding while maintaining compliance with electrical standards. Thirdly, number 6 copper SER cable can be used. This cable incorporates an insulated ground conductor, ensuring compliance with NEC requirements for safe and effective grounding. Regardless of the chosen wiring method, the circuit must be protected by a 50 amps 2-pole GFCI breaker. This breaker is essential for providing ground fault protection, significantly reducing the risk of electrical shock around the hot tub. The hot tub must be grounded in strict accordance with the requirements outlined in the National Electrical Code. Proper grounding is critical for ensuring electrical safety and preventing potential hazards. It is strongly recommended to seek the expertise of a licensed electrician to ensure that the hot tub installation is carried out correctly and in full compliance with all applicable codes and regulations. Professional installation ensures safety and peace of mind. When selecting conductors for electrical installations, it is essential to understand the different types available and their specific applications. Type THHN, or thermoplastic high heat resistant nylon coated, is a popular choice for general purpose wiring. It is known for its heat resistance and is commonly used in conduit and cable trays for services, feeders, and branch circuits. Type XHHW, or cross-linked polyethylene high heat resistant water resistant, is another widely used conductor, particularly suitable for wet and dry locations. Its insulation provides excellent moisture resistance, making it ideal for underground installations. Type OFF, or underground feeder, cable is specifically designed for direct burial applications. Its robust construction allows it to withstand harsh underground conditions without requiring additional protection. Type C, or service entrance, cable is used to connect the utility power supply to the building's electrical panel. It is available in 2 types, SEU and SER, each with distinct grounding configurations. Type MC, or metal-clad cable, consists of insulated conductors encased in a flexible metal sheath. This cable offers enhanced protection against physical damage, making it suitable for exposed or concealed installations. Type AC, or armored cable, is similar to MC cable but features a layer of paper wrapping around the conductors for added insulation and protection. It is commonly used for branch circuits in residential and commercial buildings. When choosing between copper and aluminum conductors, several factors must be considered. Copper has higher conductivity, allowing for smaller conductor sizes for the same ampacity. It also offers greater corrosion resistance and is easier to work with. Aluminum, on the other hand, is lighter and less expensive than copper, making it a cost-effective alternative for large installations. However, aluminum has lower conductivity and requires larger conductor sizes. It also expands and contracts more with temperature changes, necessitating proper termination techniques to prevent loose connections. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations in the United States. It is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Article 310.15 of the NEC covers ampacity calculations for conductors, providing tables and formulas for determining the appropriate conductor size based on the expected current load and ambient temperature. Article 250.118 details the requirements for grounding and bonding, outlining the methods for ensuring a safe and effective ground fault path. Article 400.1 through 400.11 covers the requirements for flexible cords and cables, including their permitted uses and limitations. Article 550.1 through 550.36 addresses the specific requirements for mobile homes, manufactured homes, and recreational vehicles, including wiring methods and grounding. Article 680.1 through 680.43 focuses on the electrical safety requirements for swimming pools, spas, and hot tubs, including bonding, grounding, and GFCI protection. Ground fault circuit interrupters, or GFCIs, are essential safety devices that protect against electrical shock. They work by monitoring the current flowing through a circuit and quickly interrupting the power if a ground fault is detected. GFCIs are required in areas where electrical outlets are close to water, such as bathrooms, kitchens, and outdoor locations. They are also commonly used in hot tub installations to provide an additional layer of protection. Arc fault circuit interrupters, or FSIs, are designed to protect against fires caused by electrical arcing. They detect abnormal electrical arcs and quickly shut off the power to the affected circuit. FSIs are typically required in bedrooms and other areas where there is a high risk of fire. Surge protective devices, or SPDs, protect electrical equipment from voltage spikes caused by lightning strikes or power surges. They divert excess voltage away from sensitive electronics, preventing damage and extending the lifespan of appliances. SPD are available in various types, including whole-house surge protectors and plug-in surge protectors. Proper wiring techniques are crucial for ensuring safe and reliable electrical connections. When splicing conductors, it is important to use the correct type of connector and to make sure the connection is tight and secure. Wire nuts are commonly used for splicing smaller gauge wires, while mechanical connectors are preferred for larger gauge wires. When terminating conductors at devices, it is important to strip the insulation to the correct length and to tighten the terminal screws to the proper torque. Over-tightening can damage the conductor or the device, while under-tightening can result in loose connections and potential fire hazards. Conduit bending is a skill that requires practice and precision. It involves using a conduit bender to create smooth, consistent bends in electrical conduit. Proper conduit bending is essential for creating neat and professional-looking installations, as well as for ensuring that the conduit provides adequate protection for the conductors. Electrical safety is paramount when working with electrical systems. Always de-energize circuits before working on them and use appropriate personal protective equipment, such as gloves and safety glasses. Never work on live circuits unless you are properly trained and have the necessary tools and equipment. Follow all applicable electrical codes and regulations and consult with a qualified electrician if you have any questions or concerns. Understanding the National Electrical Code, or NEC, is crucial for anyone involved in electrical work. The NEC provides comprehensive guidelines for electrical installations, covering everything from conductor sizing to grounding and bonding. It is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Familiarizing yourself with the NEC and staying up to date on the latest changes is essential for ensuring safe and compliant electrical installations. When selecting wiring methods for a project, several factors must be considered. The type of environment, the type of building, and the budget all play a role in determining the most appropriate wiring method. For example, in damp or wet locations, moisture-resistant wiring methods such as type UF cable or conduit should be used. In commercial buildings, metal conduit is often preferred for its durability and fire resistance. In residential buildings, non-metallic sheath cable, or Romex, is a common and cost-effective choice. When installing electrical wiring, it is important to follow the manufacturer's instructions and to adhere to all applicable electrical codes and regulations. Proper installation techniques are essential for ensuring safe and reliable electrical connections. For example, when pulling wires through conduit, it is important to use a lubricant to reduce friction and prevent damage to the insulation. When terminating wires of devices, it is important to strip the insulation to the correct length and to tighten the terminal screws to the proper torque. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. Proper grounding and bonding are essential for ensuring that electrical systems are safe and reliable. Electrical testing is an important part of electrical work. Testing can be used to verify that electrical systems are properly installed and that they are functioning correctly. Common electrical tests include voltage testing, continuity testing, and insulation resistance testing. These tests can help to identify potential problems and prevent electrical hazards. Electrical maintenance is essential for ensuring the long-term reliability of electrical systems. Regular maintenance can help to prevent problems before they occur and extend the lifespan of electrical equipment. Common electrical maintenance tasks include inspecting wiring, tightening connections, and testing circuit breakers. Staying up to date on the latest electrical technologies and trends is important for electrical professionals. New technologies and trends are constantly emerging in the electrical industry, and it is important to stay informed in order to provide the best possible service to customers. Some current trends in the electrical industry include smart home technology, renewable energy, and energy efficiency. Continuing education is essential for electrical professionals. Continuing education courses can help to keep electrical professionals up to date on the latest electrical codes, technologies, and trends. Continuing education can also help electrical professionals to improve their skills and knowledge and to advance their careers.